to test the convergence of this given series. So here we are going to use the d'Alembert's test, which is easier to use, where we take un to be equal to x to the power n divided by x plus n. And then we get un plus 1 from here by replacing this n with n plus 1. And then we check the limit on un divided by un plus 1. If this limit is greater than 1, then the series is convergent. If this limit is less than 1, then the series is divergent. So let's move on to the solution. This is the given series where we take un to be x to the power n divided by x plus n. And from here we get un plus 1 to be, just replace n with n plus 1. And then we find this ratio. So x power n divided by x plus n into, in the denominator we have x to the power n plus 1 and x plus n plus 1 in the numerator. We can write this denominator as x to the power n into x, so that I can cancel this x to the power n with this. So we are having x in the denominator after cancelling x to the power n and 1 here. And now we are going to take n common from the numerator and the denominator. So this is x divided by n plus 1 divided by n. And then in the denominator, if I take n common, I get x divided by n plus 1 into x. So this n cancelled out with this n. And now we are going to take the limit on this ratio. So limit n tending to infinity on un divided by un plus 1 is equal to limit n tends to infinity. So this is x divided by n plus 1 by n divided by x divided by n plus 1 into x. When taking n tends to infinity on this term becomes 0, this term becomes 0, and this term is 0. So we are getting in the numerator 1 and in the denominator we have x. And now by using the d'Alembert's test, this limit 1 by x, if this limit is greater than 1, then the series is convergent. 1 divided by x greater than 1 means x less than 1. So for this condition, the series convergent. And if the limit is less than 1, then the series is divergent. That is, for x greater than 1. For this condition, the series is divergent. So diagrammatically, if this is the point x equal to 1, for x strictly less than 1, we are not including the point x equal to 1, because for x strictly less than 1, the series is convergent. And for x strictly greater than 1, the series is divergent. What about for the value of x equal to 1? For x equal to 1, we need to check the nature of the series. So let's check for x equal to 1. We have un to be equal to x to the power n divided by x plus n. So for x equal to 1, we have this to be equal to 1 divided by 1 plus n. If I take Vn to be equal to 1 divided by n, then by comparison test, if the limit on the ratio un divided by Vn, if this limit is finite, that is, it should not be equal to 0 and infinity. If this limit is finite, then both the series will have the same nature. So summation un and summation Vn both will have the same nature. You may check any of these series. Whatever be the nature of that series is also the nature of the another series, right? So which is easier? It is easier to check for Vn equal to 1 by n. So let's consider Vn to be equal to 1 divided by n. Let's check the series Vn, whether it is convergent or divergent. We can check this series by using the p-test. What is p-test? if the summation 1 divided by n the power p, for this summation, if this p is greater than 1, then the series is convergent. If this p is less than equal to 1, then the series is divergent. Now here p is equal to 1, the power of n. P is equal to 1, that is, this condition p less than 1 or equal to 1, the series is divergent. So from p test we can say that this series is divergent series, right? So by p test the summation Vn is divergent, and because summation Vn is divergent, so this implies by comparison test summation Un is also divergent, because both the series will have the same nature. So summation Un is what? What is Un? It is x to the power n divided by x plus n. So this series is divergent for x equal to 1. So the nature of the given series, that is summation x to the power n divided by x plus n, this is divergent for x equal to 1 and also for x strictly greater than 1. So for x less than 1, the series is convergent. For x equal to 1 and strictly greater than 1, the series is divergent. So let's merge this result and write the final result. So hence, the given series is convergent for the values of x strictly less than 1 and is divergent for values of x greater than equal to 1. So for the convergence, we need the value of x to be strictly less than 1, right? Okay, thank you.